Hi everyone, welcome to my next video. Today we're going to be talking about Retrieval Augmented Generation frameworks or RAG frameworks and large language models. And the ultimate use case here is adding generative AI into your application. So this is maybe a chatbot or this interactive model that users can ask questions and they can get kind of proprietary or selected, curated, maybe is the right word here, data that you're controlling as a company, and you're not getting like the entire internet, right? Something you would get with just using Chat GPT out of the box. So the technologies I'm using here is Remix and React. You don't have to use Remix, you don't have to use React. That's just what I'm choosing here. And I'm using Langchain, which is a JavaScript framework for this. So let's kind of dive into this article here, and I'll put a link to it in the description. I just thought it was a very good article that covered a lot of kind of what's relevant to this topic. One of the first things with large language models to understand is like, okay, what are the challenges with them, right? If I want to use one, what kind of roadblocks am I going to hit? And the two that basically exist are hallucinations and knowledge cutoffs, right? So a hallucination is just a fabricated response, right? It's trying to come up with an answer. And if you've used Chat GPT or something like GitHub Copilot, you've experienced this already, I'm sure. And then the second one is knowledge cutoffs, right? So the training data, right? When was this thing last trained? So ChatGPT and GPT-4 is coming out with this browse the Bing option, or with Bing, sorry. And the idea here is that it's trying to avoid some of the knowledge cutoff. And it doesn't necessarily help you though if you want to give it custom context, right? If I want to use my data and have my customers interact with it and provide my data to it, well, a RAG framework such as Langchain is a good fit here, right? So the idea here with retrieval augmented generation is you're retrieving things from external sources and you're using that as context that you pass to the large language model such as ChatGPT. And there's other ones out there. So let's go to the documentation here in Langchain. And you'll see here it's under modules and retrieval. So this is a pretty good diagram about kind of the flow of the RAG framework, right? So the idea here is I have a source of data. I've got a lot of different sources here. It could be GitHub repos, files, web applications, anything, right? It doesn't really matter. YouTube transcripts. I want to load the data from these sources. I want to transform them. I kind of want to break them down so I can fit them in the context, right? So what does that mean? So when you deal with large language models and you have, this is Open API, and this is what I'll be using. It is paid. I just preloaded like $5 into it, and you could turn off auto renew. So if you just want to load, $1 or $2 and play around with it, I think you get, as a first time sign up, I believe you get a couple of credits to use. But there's a lot of different models here on the page. And you could go in here and you could pretty much choose one of the models. They'll give you some descriptions and really you'll see kind of these two things here, max tokens and training data. I don't think we care about training data in this case because we're kind of building the context. We don't care about its training and its knowledge cutoff. But the token limit here is really kind of their billing model as well, right? So think of a token like a word. So it's not quite one-to-one. I forget where they break it down in the documentation, but you could think of tokens as like a little bit more than a word. So like you might get 3 tokens per word. So the idea here is that you've got these tokens represent context or, words that are making up the context, right? They're your information, you're training it on. And you want to provide it to the model, and these models are basically billing you on the amount of tokens you're using, right? So you probably want to have as few tokens as possible if you can. Having larger limits is good too if you have a lot of context. And that just kind of gives you a background on how you're choosing some of these models, right? So transforming the data is taking the sources, breaking them down into chunks, and then embedding those chunks. And embedding is basically converting the data into vectors. vectors, and there's a section here over vector stores, but it's basically a particular data format that they put in vector stores, and it's just a highly optimized store. This video isn't kind of explaining in depth all of these different pieces, but hopefully it gives you enough to go and learn about these different concepts. So you're basically transforming them. You could do this through a number of different providers. OpenAI has one. TensorFlow, there's a bunch of different ones where you can convert the data and then store the data, put it into a vector database, right? You want to have this data ready to query or retrieve, right? So that last step here, I want to be able to retrieve my vectors and pass those to the large language model as context, right? So when you use ChatGPT and you're typing to it, there's something interesting going on. Let's jump over to our application here, and I'll explain the limits of this application and what would normally be happening. Now, I've trained this on micro front ends because I've been doing some videos on there, so it's got a bunch of module federation context that it's using. So I can say, show me how to use the, module federation Webpack plugin. I'll put the message in the chat here, and you'll see the bots streaming the response back to me. And we have some, kind of fancy, syntax highlighting and stuff here. And I'll talk about how I set that up. But it's not waiting for the whole response. It's just streaming it back. And it's using ChatGPT, but it's using the context that I provided it, which is pretty cool. So when you look at this response here, the one thing to think about if you've used Copilot, used ChatGPT, one of these kind of popular offerings, is that it's keeping context not only of the data it's trained on, but your conversation as well. I'm not actually doing that here. That's not in scope for the video. So every question is just kind of a new question. And just, again, this is kind of a new topic for me too, so I hope it's a good kind of gateway into kind of the understanding, and you can dive deeper. So we have Langchain, we kind of roughly understand the flow. Let's kind of dive into the code here, and let's look at what's going on. So this is a remix application again. I am using the Vite integration for Remix. Again, you don't have to use this. You can use Node, any backend really, as long as you can integrate with OpenAPI, and just whatever front end you're comfortable with. So I'm using Remix and React. So in my root here, I just have a really simple React or Remix application. Right, there's not a whole lot going on here. I have these routes. And when you look at the routes here, I have chat. Chat is an endpoint here. We'll talk about it. I was originally going a little bit of a different direction with Remix and thinking about using some server state, but I wanted to keep the example simple, and I didn't want to put too much in there because everyone's familiar with client state, and it kind of makes sense for this demonstration. So this is an endpoint. We'll go back to it, and we've got the index file here. I would put a link to this repo as well in the description. So I have my home component. My home component has 3 pieces of state. One is the last message. This isn't really the best option, but it's basically the current message that's being streamed back to you. You've got the list of messages, so the user messages along with the bot's messages, and then an indication to say if it's loading, and that's that little skeleton loader there. So I've got this handle chat message here, chat messages, chat message, and chat messages. And then basically my display. So let's kind of go into the markup here and look. So I've got a text area. This text area has this handle chat message here. And then basically above the chat message is basically just a bunch of chat messages, right? So exactly what you would think a chat is, right? Chat box on the bottom, your list of messages kind of going down. So let's go to handle chat message. So basically anytime you hit enter, it's going to come in here. It's going to grab your prompt. It's going to put your prompt in the array of messages so it shows up. It's going to set loading to true. And again, this isn't production code. This is an example. You're fetching this local chat endpoint, passing it the prompt as the query string. And then that's going to call this chat endpoint here. And let's just kind of go through what this is first before we go to the backend. But basically, it's going to use this readable stream. And it's going to stream that response back. And the great thing is if you're using Langchain, they have a streaming page here, and it shows you, this. Like if you're using Node, you can stream this back. It's really that simple. So in this case, we got the response back, and we want to start parsing or reading the stream. So we're basically just going to kind of sit in a loop until we finish, right? So it's going to basically go through here. The promise is going to come in, and it's going to grab this read stream, right? So it's going to grab the reader. It's going to call read stream, and it's going to basically just kind of call this in a loop, until it's done. And then when it is done, what's going to happen is it's going to set that message. So it's just kind of concatenating the data. It's like just decoding the information that's coming out of the readable stream. It's just concatenating it. And then when it's done, it's throwing it in messages saying, hey, it's from the bot. And then, nulling out the last message. So we don't see it anymore. It just becomes part of messages. And that's just, a memoized thing. I'll show that. And then it's releasing the lock. At this point, it's done. It doesn't need it anymore. The request is done. I've streamed everything, released the lock out of it, and move on. So chat messages here it's basically just, looping over the state messages, and it's just creating these. It's just memoizing them. So, again, the idea here is just that there's going to be a lot of re-rendering because we've got one monolithic component, which is one problem. And then the second problem is that we're, setting that last message over and over again because it's streaming, right? So I just threw these in memo for now. It's, just pretty simple. And I'll go over chat message here after we kind of look at the back end, because there's a lot to this. It's actually pretty interesting. So let's go to our back end point here. So I'm using a loader. This is just Remix specific stuff, but this would just be an endpoint here. You'd grab the request coming in, grab your search param, and you'll see that I'm calling this singleton object. This is something from Remix too. And let's just kind of break down the intention behind this. And the intention behind this is that I've got data sources. I want to go, in this case, I'm using YouTube transcripts, and I'm using a website, and I'm using just a normal text document, and I'll show those. But every time you make a request, I don't want to go ahead and re-download those and put it back in the vector store because I'm using an in-memory vector store, right? I just want this example to be simple. In a real app, you'd probably be hosting your database separately and, worry about high availability and all of that. But in this case, I'm calling out saying build RAG, right? So build RAG, let's jump into it. This is kind of what it does here. So it takes in a bunch of different sources here. So if you look, I've got this promise all, and it's going through YouTube loaders and web loaders. So I've got a list of YouTube videos that it's going to go use those transcripts as the context. I've got just a simple Medium article here. And then I'm basically just mapping these back to the document loaders that Langchain has. So Langchain provides a bunch of different loaders. I think you can write your own loaders too, but there's a ton out of the box. It's a great framework. And it's just basically calling their loaders, passing it these URLs, and then what you're getting back is a promise of documents, right? So documents have, again, all of that text content, right? So it's awaiting them. And when it comes back, it's like a two-dimensional array. So I'm just kind of flattening it real quick. And then I'm pushing in just a simple text document here, just as an example of being able to train it on anything, right? It doesn't have to come from the loader. You could put any, arbitrary data in this thing. And there's even kind of a key value pair, like a property bag, metadata that you can put about the document in the document collection as well. So now that I have my documents, I'm going to use, OpenAI here. And OpenAPI, again, it costs money, but you can load, $1 or $2 on there, and you can play around with this. And I think you get a grant for the first time you register. And if I go back to Langchain and I go to Quick Start here, there's just a really simple guide you can follow that'll tell you what environment variable it's looking for, give you a very simple example of building a very simple chatbot. And it's really a great place to get started. I leverage a lot of code from their examples in my example. So here I'm just saying, hey, create a chat open API object, enable streaming, and this is the model I'm going to use. And again, these models are on OpenAPI's documentation. So I'm taking the documents that I produced up here, I'm splitting them. So I'm saying, okay, use their recursive character splitter. So it's just what they recommend. Again, it's in their documents. So if you go into the retrieval documentation, it'll give you samples of their loaders, kind of what I was just showing you. Then there's the document transformers, and it'll show you what it recommends here as the default, which is this recursive text splitter. And it's going to be splitting on things like new lines, spaces, things like that. And the goal here is to try to take all of this data. It could be, tens of thousands, millions, hundreds of thousands, whatever it is, right? And it's trying to break them down into chunks so that it can help with the token limit on the models, right? So if you go back to the models, you'll see max tokens here. And again, this is your biggest challenge, and this is what you're being billed on, right? So, these tokens are what cost money. It's what you're being billed on. And this is the limitation of the VM, or not VM, AI. So with this as well, you have to think, if you want to keep kind of conversation context, right? And you want to kind of store your conversation too, that's going to go against your tokens as well. So that's out of scope for this video. Let's just kind of keep walking through the example here. So I'm choosing just an arbitrary chunk size of 2000. I'm saying there's no overlap, and I'm splitting these up, and you get back documents, right? So you're passing in documents, you get back documents. It's just documents, right? So at this point, it's pretty simple. I'm using their in-memory store here, this hierarchical, navigatable, small world graph. And this is their, again, if you go back to the documentation here and you go down to text embeddings, they'll show you just, different services, or, TensorFlow, OpenAI, there's a whole bunch of them. And then there's the vector store example, and they'll actually show you, how to use this memory vector store if you want. The one I'm using is just from another one of their examples here, but basically, I'm taking these documents. I'm going to be using OpenAI embeddings, and it's going to create this store. It's going to set the store, it's going to create the store from those documents, right? And it's going to create this retriever, right? So if you remember from that diagram, we have this retriever. So at this point, the database is here, and it's set up. It's ready to go. It's in memory. It's got this system template here. So this is context that it's feeding in on every prompt. You just don't see it, but it's basically saying like, hey, if you don't know, don't make anything up. Just say you don't have the answer. And then whatever context we are providing it, in the context here, this is done automatically kind of through Langchain. So this is nice. It's tied together here. So let's keep going through this, and it'll kind of make sense. So we're basically giving it, every time we put something in, we're giving it two messages. We're giving it this template here, this system message template, and then we're giving it the human template, which is your question. So if we keep going down here, you'll see prompt. So it's creating a chat prompt from here. So now it's taking these messages, converting it into a prompt, and it's got this runnable sequence here. So the runnable sequence is it's kind of chaining things together, right? It's a sequence of, actions. So what it's chaining together is it's grabbing the vector store, and it's got this format document as string. This is just, an import here from, and again, this example is in their examples too. They have tons of examples. So you could kind of almost get this code verbatim on the documentation. So it's just going through, it's creating this kind of processing middleware, and it's just kind of formatting the documents as strings. So it's taking all of the documents here that we put into the the vector database, it's piping it through this middleware that's reformatting it as a string. And it's got this runnable pass-through as a question, and it basically means it's not doing anything. And it's passing the prompt. It's passing a reference to our model, which is this up here. And it's just saying it's a string output, right? And it's a very simple parser. And then this is our chain. Now, if you go over this, it'll be a runnable sequence. Again, a lot of their documentation explains this more in depth, the chaining and sequences, but let's just kind of jump back here. So that's basically what this code does, right? It goes in, it loads, it embeds, it transforms, it creates the vector database, and it creates the sequence, and it passes that back. And I have my sequence here, and it then calls this prompt large language model, which is back in that file. But if I go back to it, it's right under this code. And it just takes in this chain and it calls stream and it passes in my prompt and it returns this promise out. And this promise comes back here. And now it's just streaming the data down. So if you want to have a streaming response, they have documentation on how to do streaming. It's very simple. It's basically the same code that I'm using. Now, there was a small issue that I couldn't figure out with Remix where if I passed it the stream, so like, again, let's go back to their code example. You know, inside of here, instead of logging it, if you were using Node, you'd have like response.write. We're not using Node, so we don't have that. So I tried passing it just the stream, which it'll take. You could pass this in here and it'll work. But the problem was it was closing the stream in a weird way. It almost felt like a bug on the Langchain side, or maybe how Remix is doing things. And it was throwing an error. So the easiest way to kind of avoid it was to basically kind of pipe the stream through another stream. And then, this is basically just, kind of piping that data through. And then I just return that new stream object. And again, this will be in the description. Now, when this data comes back, let's kind of look a little bit at what the response looks like. So I'm just going to pull this up here and let's ask it a new question. Let's say, what are micro front ends? We'll ask it a question. So you'll see here that it is streaming. It's actually, has an open connection. It's streaming them down. If I click on it and I look at the response here, you could see that it's just text, but when you have these rich examples, so let's do this. Let's copy our first question here and let's go down and let's paste it. And let's look at this kind of rich kind of format that it's coming back with. So there is, they're not super fast, the large language models. And again, that's why you don't want to do all of this on every single request, right? You want to load your vector store and just kind of retrieve from it. But the large language models, they are a little slow. So you want to have a streaming option like this. So you have the best user experience possible. And then, just the way that the context is broken up in those chunks, right? You just want to have things that it's easy to kind of find it here. So it's went through, it's given its answer. And if you look at the response here, you'll see that you have this kind of markdown type response that you would see with something like GitHub as an example. And it's really just kind of handling these, right? We just have to have some type of parser, right, on the client side. So if we go back to our client side code, you'll see here that we're taking that data back again, and we're just reading it as a string, and we're putting it in the set messages here. And you'll also see that that's when it's done, it's putting it in messages. But as it's streaming, it's just churning state and React, right? It's just saying set last message, whatever the last value was. So it's just re-rendering kind of constantly, right? It's not super efficient, but you can see that streaming text come in. Now, we talked about, if we look at the rendering here, so it's rendering something called chat message, which is this. So it's going over chat messages here is just looping through all the messages, but then the last message is always displayed at the bottom. And it's just calling this little component here, chat message. And I could have broken these things apart, but it's just a demo. Now, chat message is just a component, and it's taking in a chat message, which is where is it from in the message. This is just my own custom type up here. It's nothing out of a framework. And I'm using this markdown component. So the libraries I'm using here is React Markdown and React Syntax Highlighter. And I'm using a YouTube embedder here, but you don't have to worry about that at the moment. So I'm using this markdown component. Definitely read their documentation here. I'm varying the the text, right? So when it takes the text in or the markdown, it's just looking at the from and it's prefixing it, right? So when it's me, it'll say me, and then when it's the bot, it'll say bot, right? So it's just prefixing it. I'm using Tailwind, so it's just putting a selective class here, just some styling differences on it. And then it's got this components object here, right? And what's interesting about this is it lets you intercept different components that Markdown's rendering. So this is specific to this component. Remember, we're just dealing with text, right? But in Markdown, it's dealing with basically primarily two different elements, right? One is the paragraph tag, the other one's code, and we're just adding handling in for this, right? So this is specific to these components, but I just want to walk through. You've already seen pretty much everything RAG is, right? This is done. This is just how I'm formatting it, right? So for paragraphs here, this is basically just for video. So let's collapse that. Let's look at the code. You basically have this little function here that takes in props, and then you can actually look at the class name. So it'll parse through Markdown those ticks, right? So if you go back here, the 3 back ticks in JavaScript, it'll parse that out, through Markdown, right? So it's coming in, and they call it class name here as the variable, and you basically just run a simple regular expression. You pass it to their syntax highlighter. You give it the language, right? Language dash whatever. And I'll show you an example of that. So if I click here, you'll see that under here, there's a code block, language dash JavaScript. And that's basically it's trying to figure out, does this have special syntax highlighting, right? And if it does, give it the language. And if it doesn't, give it an empty string. And then that basically comes out this block up here, right? So this one doesn't have a language. So if I go here, you'll see there's no language. And that's what it looks like. Otherwise, it'll allow you to do fancy syntax highlighting, right? HTML, JavaScript, TypeScript, whatever. And that's the syntax highlighter. So again, you can get pretty fancy with this, right? It's not just relying on their syntax highlighter. What if I wanted to have a YouTube video? So if I go back to my RAG implementation, and I look at my custom, I just put some text in here, the following YouTube video. So let's try to get it to give me this, right? So I'm going to go down here and say, give me a YouTube URL. Let's see if this prompt's correct. And you'll see that it'll render the text and then render the video that I gave it, right? So I can come in here, I can click it, it'll play. This is just another component I'm using. This one is called, let's see here. I'm just all over the place, sorry. This React Lite YouTube Embed. You could write this yourself. This was just a quick component I grabbed. And what's cool is, let me scroll back down here. So this is just that paragraph handler. So if I go back to the, let's see if it shows up in network here. Oh, there's a lot of stuff. Yeah, so you'll see in the text here, it returns just the video, right? There's nothing special. But then in the Markdown, they're using the paragraph tag, right? And I just found this through kind of debugging it. But I handle the paragraph tag. I give it this regular expression. This is just kind of simple. And it's trying to decide if it has a video. If it doesn't have a video, just render whatever it was, right? Just render the text. And if it does have a video, then show the embedding and use, parse out that through the regular expression, the video ID, right? Which is just part of the URL. And then that's it. Now you can have, special handling within your chatbot. You can kind of embed anything that you want here, right? It's really up to you. And really what you're doing is you're taking whatever your knowledge set is, right? So you could build kind of a little chat bot around anything, right? You could give it the context here, and you are essentially just saying, okay, well, I'm going to retrieve my context from the data store, right? So you're prepping it just like you would with any database. You're kind of ETLing in, and then you're retrieving it out, and then you're passing it back to the large language model saying, only use this. And again, if I say, tell me about, I don't know, bananas, right? So it'll just say like, I don't know what that is, right? So just as an example, just to make sure that it's not, sourcing things, it's not hallucinating, it's using the context that I give it. And this is great because again, if you're building something for, your company and you want to have a custom data source and you want to have the large language model feel where it's able to kind of interpret and find those answers in the context you're giving it without having a kind of dialogue framework where you're kind of, mapping out very specific questions and variations of questions and keywords and, all of these different things. This is a pretty good option. And obviously you can spend time and tweak this and learn kind of how to make this a more of a production grade application. Anyways, I really just want to say that at the end of it, this is a new topic to me. I'm definitely learning here. Remix is a great framework. I'm not really using the full power of Remix here, but it's just a framework that I like. And Langchain is definitely another great framework out there. I'll put links to it in the description here. And if you like the content, please like and subscribe. I'll have future videos, or if there's something that I can maybe dive into on this topic, I'd love to hear it. Thanks.